Master of all modulation. So it's a plain surface, basically right here. So we have 16 of these these linear softpot sensors. And what happens is when you play, it senses where you're playing on the key, and it works on all the keys kind of separately. And what we can do is we can change, depending the place that you are, we can change what filter you're affecting by this little switch.
And the softpots are like, they're like a regular potentiometer slider, except for that you have to like, you touch and you can like change the location instantly, which is nice. And originally we had them just bare on the board, but that was really hard to play because they're smooth and you have to like look and see where you're playing. So we put these neoprene strips over them, which just made it like way more tactile and like comfortable to play. And then the other main part, I guess, are the trackballs. We wired it so they light up when you move them, and it moves both of them since this one doesn't work on its own. And in this mode, they should be controlling delay. So you get a wet dry there. And then we have these rotary softpots, which do volume. And the other one turns the LFO rate up and down, and the pressure of the trackball turns the LFO on and off.
So yeah, under each trackball we have two force sensors, force detecting sensors, and so every time you press down on either one, they do two different things. So
that one has like a format filter hooked up to it, and it changes the XY position of the format table.
And yeah, then we have. So yeah, this changes the LFO rate, so and then this rotary switch on top, it changes what filter we're applying to the sound. So and the cool thing is that we're sending each of these softpot keys to separate channels, so that means that instead of the pitch bend affecting both notes, we can do pitch bend individually. So we'll change a pitch bend for each key, which is like the filter cutoff. Yeah, so this one is cycling through our wavetable.
So you can see we have these little black strips on the rotary softpots. That's because we found out that if you touch the beginning and the end of the softpot at the same time, it makes them really hot and burns a hole in the softpot and then melts the plastic behind it, and you have to buy a new $15 softpot.
One of these, the top left here, will unlink the different rows of buttons. So if you have them linked, then this is an octave up and an octave down for the different notes. And then if you unlink them, then you can have this this side of the softpots be playing at a different octave than the other. And then this button up here switches between velocity mode and the normal mode. So for velocity mode, if you have that button depressed, then along with changing whatever parameter, you can also change the volume of the note.
And we also have this foot pedal. All the notes are configured to one scale. So a blue scale, but now if we hit this, that's pretty nice, and then we can go the typical traditional scale, and then we have the minor scale. So
since we're sending each note to a different channel, we have to have 16 of these subpatchers, and each one takes a note. So
is that one?
Yeah. So it does a few things. It tells when you're pressing it and the position. And also when you release, it sends a note off so that you can hold down a note for however long you want. For the FSRs under the trackballs and the trackballs themselves, they're affecting all of the channels at once. So it has to send to all the channels because there's only one note per channel.
In here, we have 2 Arduinos, we have 2 Megas,
Because
because
we used all the analogs for the soft pots themselves on one of them, and then we need another one for the force sensing resistors and the additional soft pots that we added.
so how the max patch works is it sends a request to the Arduino. The Arduino sends back all the data pins that you want, essentially. So the only thing that we had to do is, since we wanted to turn on these LED lights, we needed max to send back data to the Arduino in a different form. So basically the trackball internally, it stores the last counter for its like X and Y position. So the Arduino is continuously, every time it's in a loop cycle, it's pulling the trackball and saying, okay, what's your last X position? What's your last Y position? And then that's just getting sent back to the max patch.
Then the second half of our instrument is a sequencer mode, and unfortunately it doesn't elegantly switch between the 2 patches, but there's a switch at the top, and when you flick it, it turns the sequencer on. You can press start and set some nodes.
So every key now behaves as like it would in a step sequencer. This is really fun because, as you can see, demoing some of these projects are pretty hard because we haven't had a lot of time to really work on figuring out how they sound. But this gives us great like expression because we still have access to all of our filters and we have access to all the keys. And the top section is the note that it's playing. So as you can see, it's cycling through a pattern of notes. And the bar underneath is gonna be applying filter. I think that's filter cutoff at the moment. And the one below it, wavetable position. So now our rotary switch behaves as alternating between those 3 different parameters.
Yeah, so the reset button resets the parameters, and when the Alt is pressed, it resets the notes. You can change what key you're in, so you can kind of go up the scale. It also makes this to control tempo.
Oh, right.
And
This guy controls portamento, so you get some nice slide.
we had to kind of build a sequencer from scratch because of all the things we wanted to control. Every time it sends a note value, it sends the corresponding parameter, which are these 2. Also, we have these randomizers, which have to send to all the values when you spin it.
This one will randomize the wavetable position if you spin down, and then if you spin up, that'll randomize the filter frequencies.
Reason
We have
is a
16
whole
of
bunch
everything.
of Thors. So we decided to use Thor because there are just so many more parameters that you can mess with compared to Subtractor.
So yeah, that's the format filter, the pressure on the right trackball. And then the left trackball is LFO. So we have the LFO, we have this rotary button controlling how much LFO is applied. So that's sending it to the filter 3 frequency, the filter 1 frequency, and the AM on oscillator 2.
Because there's no polyphonic aftertouch in Reason, we had to make a separate Thor patch. And for that reason, it's a little cumbersome to have to change things and modify it all, but
And it's worth it because of just the pitch bend. The fact that you can have pitch bend on each channel is really cool. That's pretty much the basis for why we did it that way. Everything is just basic right now. So we can tune it, we can set, this is our base note. So we can do is then, which mode are we on? All right, so we can change it to, yeah. So now we can just change, if you look, we can see each note individually. And you can kind of style this how you want. It's very cool.
you also turn notes off by going all the way to the top.
And then, so once you've established some sort of sequence you like, you can change it, and let's say we want to adjust the filter on some of them. So we go Like, so now you can see the top one is going to have a like sharper sound. I think. We'll adjust the wavetable position a little bit. Alright, that sounds pretty good. Now we can sort of add some extra modulation. So this is putting pressure on this trackball, add some like format filters. That's pretty cool, I like that so far. Then we can like add some portamento if we want, and even some noise. And then let's say, okay, let's oh, now it's getting pretty wild. Might have to tone it back a little bit. Alright. And then we can just continually like... And then let's say we want something new, so we just go... And then we can always reset it. So there's a lot of fun times you can have with this thing.